Hello, everybody, and welcome to Handmade Hero Show, where we code a complete game live on stream. We have to do some. We have to put our thinking caps on today because basically what we have to do now, because I think we are mostly done with asset processing. We tried out some asset processing in various ways, and it seems to actually work quite well. And so we're mostly, I think, down to just stuff that will sort of fine tune along the way. But there's a sort of a big issue that we've got to deal with that I'm not sure how exactly we're going to deal with it, because there's a lot of, we've got options basically. And if we go out here and look at some of the stuff just in debug mode here that we've got, you can kind of illustrate the point. So if we take a look, let me move our weird blobby thing over to this room here. So if we take a look here, we've placed a little cat in the room. And you can see our art imports doing exactly what we want it to do, which is it brings in all the art and it tagged it properly. So this is asking for a gray tabby, and it's getting a gray tabby, both the head and the body and so on. And it's asking for the head one and the body and the other and whatever. And so that's all real good. But then you see we get to this point of like assembling the cat. And we don't really have any tools for assembling the cat right now. And the art that we have is intentionally made with separated heads and bodies for pretty much all creatures. That's just the grammar. And that's there because we may want to do like swapping and stuff like that. Like we may want to be able to put different heads on different bodies and so on. Maybe not necessarily with the cats, but certainly with all the rest of the creatures. And who knows, maybe even with the cats, it's hard to say, right? And so what we have here is a case of needing to augment, right, our artwork with information that is not intrinsic to the artwork itself. And in game development, this is a very common problem, and it's a common problem specifically because art tools are terrible. This is just universally true. We would like, ideally, to have the things which our artists use to make assets for our games intrinsically understand everything about the assets that they need to understand in order to output the information we want, right? In other words, ideally, if Anna's drawing a cat in Photoshop, Photoshop would also have a really clean way of knowing that our game needs to know what's a head and what's a body, what the tags are for various things such as that so she can pick them from a list, the ability to define new tags and export them to some kind of data format we can recognize, the ability to place alignment points that are also themselves marked so we know how the head goes onto the body, and the ability to place like measurement markers that say how big a particular thing is. All of these things would have been really great, and then we could have just loaded in a data file that had exactly what we wanted, right? But that is never the reality in games. Art tools are made entirely for other people, essentially, even though you get a lot of attention paid to games now in some tools like 3D Studio or Maya, for example, right? They still seem to overwhelmingly be designed not around what we actually need them to do, and it is always this kind of shoehorning process. The end result is always this really ugly, unsavory, systemic, I don't know what you want to call it, it's almost like a Rube Goldberg sort of contraption that is created for every game, or at least every game engine, that requires some set of steps and some set of hacky additional data that augments the art that gets exported in order to properly capture the information that's necessary to actually represent an asset in a game, not just a bitmap like you would post on Twitter or a rendering that you would output to a movie or something like this, right? And it's not that games are particularly special. They happen to be the hardest case for this sort of thing because you typically need a lot of information about how things can be interacted with and how they can be modified, because games are all about interactivity and modification. But this is true even in movies. Like most movies have to dramatically augment their pipelines from whatever art tools they have, just because, again, it's like our jobs are just more complicated than art tools typically are able to accommodate. And a lot of times because there are no standardized ways of doing things, and you're always sort of pushing an envelope somewhere. Even if an art tool managed to internalize some process that was what we were doing 5 years ago, by the time they actually get it into an art package and shipped, it's usually old news and not actually what we're doing anymore anyway, and still obsolete, right? And so this is just a fact of life, is I guess all I'm trying to say. It's just the way things go, and it's not really going to get any better, probably. So fortunately on Handmade Hero, we're not trying to do anything too elaborate. We don't have really complicated 3D assets with all sorts of additional texturing and markup and stuff like this, and hitboxes and collision and physics and all these sorts of things that would create a really onerous load on us in terms of how we integrate all that data together and create art assets that we can actually use in the game. We have a much simpler problem. We just have bitmaps, and those bitmaps can largely be used exactly as they were exported, so we had a pretty easy time devising a way of getting those into the tool without too much trouble. But we have now come to the point, and to be clear, you saw me work around limitations already, right? We used a grid to avoid having to have lots of PNGs. And we used the file name to put tags in, so we didn't have to have a metadata file for each individual thing that specified those. But now we've come to a point where we really do need to start thinking about adding whatever the minimal amount of metadata is. And the reason we have to think about that is because there's no other way we're going to be able to deal with this kind of scenario, right? The data about where the head goes on the body of this cat, or where the head goes on the body of anything, right, is simply not present in the art data. And it's not present because it simply cannot be present. There really isn't a clean way to do it. And if we were to create a Photoshop-based markup system for that, it would probably just be a waste of time. The reason it'd be a waste of time is, A, artists would have to learn it because it's non-standard. There isn't such a thing as body-head alignment in Photoshop. So we'd have to make up a grammar for that. Like, place this knot of a fake curve, or make a layer called this and stick it here, right? But more important than that, because that would not be that bad. Like, we could say, artists, here's how that goes. The worst part is artists can't see the results, right? They have to wait, they have to export out of Photoshop and then wait for the game to reload it. And even if we make that path really fast, it's this kind of nasty, like, they can't, you want the tool you're actually working in to show you the result, right? That's the real thing that tends to be the blocking factor in a lot of these art tools, is the artist needs to be able to see the result. And you want the result immediately if you can. You don't want to have to wait for Photoshop to save a PNG out, And so, yeah, it's not great. So what we would like to do potentially is just say, well, can we just make a way of us placing it in here, right? Because if I had a way to just sort of say, here's where the heads go on this thing, and here's the attachment point, here to here, that would give us exactly what we need, right? It would allow us to instantly specify that. And then we don't have this round tripping problem where you're going to be fussing with it and trying to see what ends up looking right, and other sorts of stuff like that. So I would like to be able to create some kind of system for doing that. And actually being able to make that markup isn't really all that tough, probably, right? Like, just displaying a bitmap and having us pick a point on it or something like that isn't particularly difficult. So that part isn't really the interesting part. It's a little bit of grunt work, but other than that, it's pretty basic. The problem that I think we're going to have to think about hardest is not that, but rather, where does that information go? That's really the thing that's a little bit more troublesome, right? And so the problem that we have is, right now we have a notion of sort of authoritative and non-authoritative art resources. And this is very common in games. It's in fact common in pretty much all of computer software engineering at all. Which is to say that if you look at, for example, our executable isn't authoritative, right? The C files that build the executable are. It's just assumed that you could delete the executable at any time, and you can rebuild it from the C files. So having the C files gives you the ability to build everything, the OBJs, the executable, the PDB, they can all be built from the C files. So the thing that's authoritative there is the C files. It's not the executable because if you deleted the C files, you could never get them back. The executable is not sufficient to regenerate the C files, right? And the same is true for our HHAs. They are not authoritative, right? The PNGs are authoritative. They store higher res versions and original versions of the artwork, and we take out pieces, munge them around, and produce like final versions for use in the game from those PNGs. So the PNGs are authoritative, the HHAs aren't. So normally what we would want to do is write the data back into the PNG, for example, since that's the authoritative thing. We would like to say, oh, that PNG now has the information, so it's authoritative. Unfortunately, our problem goes one deeper than that. The PNG really isn't even the authoritative thing. It's the Photoshop file that Anna used to make the PNG that's actually authoritative. And there's no way we're going back to that because we don't even have those files on this machine. We just get the exported stuff, and the PSDs are stored somewhere else, right? Now, we could have made a PSD-centric export path. That would have been interesting. I have done that before, but there's a lot of things that go along with that I'd rather not go into it. Let's put it that way. So we could have done that, and then maybe what we could have done is reinsert data back into the PSD, but then again, you would even run into problems where we would be doing that on our machine, and then if Anna was working on that PSD at the same time, she would clobber our changes potentially. So you see, I'm just trying to give you some appreciation for just how complicated such a simple thing can actually be because of its insertion into the process in an unfortunate place. So typically what we do to solve these kinds of problems is we create a separate file, right? So instead of having the PNG be the only authoritative file, or the PSD for that matter, we augment those files with an additional text file input of some sort. Or it could be binary, it doesn't really matter. Text is usually preferred because then you can edit it with a text editor or merge it with a change utility, but a binary file is fine too. It's just a little harder to work with sometimes, right? But the point is there's a second file. So you got .png, but you also have .txt or .whatever, and that extra file contains whatever data the game wanted to augment that art asset with. That way, when you go and know that you need to re-import a PNG for some reason, you also re-import the .txt or whatever it was with it, and that file contains the additional information that simply couldn't be flowed back up the pipeline. So it basically creates a bifurcation where you say, look, authoritatively there are two files that combine to make this file, one of which we change in the game itself, that's like markup specific only to the game, and one of which the artist is free to modify in the tool of their choice. We don't really care what that tool is, and as long as that tool can output a PNG, we're fine, right? And so I don't want to say that's a good solution to the problem, because a better way to say it would be there really isn't much of a good solution to this problem without going way further down the art tool path, right? To places that are themselves entire projects, if not products, that you could even sell, right? So like the text file method, which is a very common method, is the easiest way to solve or work around this missing data problem, where you've got data you need that the art tool simply doesn't provide a convenient method for creating, which will hit you pretty much in every type of game you will ever make. It's bad enough in 2D. It's still a problem in 2D games for sure, like we're seeing here, but it's even worse in 3D. It just gets worse. It always just gets worse, right? It's a problem that gets worse forever. And the only thing that really makes it, if it is more tolerable at all in 3D, the only thing that makes it more tolerable is that art tools are used to in 3D and artists are used to dealing with in 3D markup. adding skeletons and bones and helper objects and naming them all and having that skeleton come out in the export and all that sort of stuff. That's a very common thing to work with and understand in a 3D pipeline. It doesn't exist in the 2D pipeline very much, largely, again, because the tools just don't have it. So, you know, if you ever do skeletons and stuff like that in 2D, it's augmented by a secondary tool, right? Like Photoshop doesn't even do it, really. So you end up having to have like, okay, the artist exports them out of Photoshop, then they load it into some kind of a like spriting tool, like Spriter or something, that allows you to put bones in there, and then maybe you add the markup there, right? So it's just, while it is a much harder and more extensive problem in 3D because of the amount of additional markup you need, sometimes paradoxically, it's actually easier to deal with in that realm, and the reason is because the tools always have built into them all of this additional markup because it had to be there for other reasons. Whereas 2D, as usual, you know, Adobe mostly just sucks their thumb all day, so you end up in a situation where that stuff just isn't there. You know, why doesn't Photoshop have a really complete, very good bones animation tool by now? Because it doesn't have to, right? They'll sell copies either way. So anyway, that's basically where we're at, and just to give you an overview of that problem. Otherwise, I think we're in good shape. I think we've got everything else we need. And so our goal now for this weekend is to figure out how we're going to solve that problem, because then I think we're ready to go on characters as well. We didn't need to solve this problem for environments, and the reason we didn't need to solve it for environments was because we understand how our blocks are wrapped with textures, and there isn't really any need to mark them up, right? There was no additional information. We were able to define entirely intrinsic to the art itself a rule for how we were going to process that type of artwork. And so that's why we didn't have that problem. But for characters, as much as we would have wanted to be able to do the same thing, there really isn't much of a way to make that work. You know, there were things I considered, and I just felt like they were a little bit too silly and ridiculous to try and go down. So I thought this would just be a place where we're going to have to bite the bullet and add an augmentation. So I think, like I said, we just want to go ahead and do a basic text file augmentation. Why text file and not binary? Because generally speaking, I think that in this case, simpler is better. And while I prefer binary files typically to text files, honestly, that's only once you've gone a particular distance down your toolkit approach. Like, you know, you want to be able to diff these things, and if you're never going to write like a diff tool for your binary format, and you're not going to invest in this binary format long term, then text is better. There's a break point there where if you're only going to spend a little bit of time on something, text will win, because there are way more text utilities that you can just leverage, and binary doesn't really have that same sort of thing yet. I think someday it might. There are people who've done work on arbitrary definitions of binary files and stuff. I don't know if you've ever seen that. There's a project on GitHub for like making like little grammatical descriptions of binary files. You know, things like that eventually I think might start to create ways we can stop relying on ASCII so much, which I don't think is a very good format for storing pretty much anything. But at the moment, just because of the way tools work, it is better if you're only going to spend a little bit of time. So I'm going to go ahead and load up here, and I'm going to make, I'm going to say, you know, here's our art directory, right? I'm going to go ahead and make a imaginary addition to this art directory, and I'm just going to write it by hand first, right? And so what I want to do is I want to write a text file by hand that's going to experiment with what we could do to mark up this stuff with what we need. And then we're going to flow that back through our pipeline, expand our definition of an HHA to include what we actually want to have in here in that respect. And when I do that, we will get to see it all work and make sure it's valid. And when we're all done, then our task, say, for next weekend can be to write the editor part in the game that allows us to quickly make those modifications visually and save them back to the text file. Right? And off we go. In some sense, you could think of this as, look, we are just going to augment our HHA with the data we need, and we're just going to write stuff back to the HHA so it's always correct. The text file is just a way of also saving that data, right? And the reason for that, like I said, is that HHA isn't authoritative, so ideally we want to be able to just delete and rebuild it anytime we want, because it's our shipping format, not necessarily our editing format. We don't want to have to, we want to be able to update like the format of our HHA and delete it and rebuild it anytime we want, at least up to a certain point. And so, you know, we at least, at the very least, even if we didn't save out the text files automatically, we would at the very least want our HHA edit tool to be able to unpack an HHA into text files that did have that additional data or something like that, right? So that we can rebuild the HHA as necessary, and so on. Okay. So let's suppose we were going to work on character cat Berman ghost here, right? Or I guess let's do Gray Tabby, because Gray Tabby is the one that was in that room that we were looking at there, so that may be an easier way to do it. So if I look at character cat Gray Tabby.png, if I just do a markup file here, so I make a text in here that goes with it, what we know from looking at the tool here, let me just go ahead and not the tool, the source file. So what we know from looking at the source file, right? Oh, that's weird. If you zoom in far enough, it handles the alpha properly? What? What? Is there a rationale for that? Oh, okay. So I think I get it now. They're scaling, so their downsampler doesn't handle alpha, but their upsampler does. Right? That's probably how big it is in the actual file. If you go below that, the alpha's wrong. If you go above that, it's fine. So nobody ever tested, like at Microsoft, they were like, didn't test the downsampler for alpha. They're just like, I don't know, man. But for some reason, whoever wrote the upsampler, maybe they was the same person, I don't know, but they had a bug in one and not in the other, I guess. I don't know. That's crazy. But there you go. So mystery solved. I always wondered why the alpha was broken in it, and now I know. Never noticed that before. Anyway, back to our story. So in each of these cases, right, we know the alignment point for where the head would go would be specified in each of these sort of each of these turns, right? Like the head goes here or whatever. So we know we'd have an alignment point that we would want to write out into the file for each grid position potentially, right? And same with the heads themselves. We know that there's like an alignment point there or whatever, an alignment point there, and so on. So we know we've got, like for each grid square, we know we have an alignment point that we want to place in there. You know what I mean? And that alignment point would basically give us the information we needed to align heads to bodies. And we could also have alignments for other things, but I don't. So I guess we do know one of, now that I think about it, we do know one other thing too. So we had hats, for example, that can go on to heroes, and I mean, I guess there's no real reason they couldn't go on to that they couldn't go on to cats as well, right? You just shrink it down or whatever. And so we do also have an additional placement situation here, which is to say that heads also have a like adornment that they can put on as well. So if we take a look at how that's going to work, it means that we sort of have an idea that a particular grid square has information associated with it. And we probably want to say, if we look at a character here, a character template, right? we know that we've got sort of these grid squares numbered like 0, 0, and then over, right? Going down the y and over an x. That's the way we numbered them when they come into the file. Because again, PNGs start at the top and go down, and that's what we're loading here. So, you know, if we wanted to specify like a grid square, for example, right, we could say, you know, we could make some syntax, and I don't know what that syntax should be, right? But we can make some kind of a syntax for saying, look, what's the grid square that we're talking about here? You know, what's the actual grid square we're talking about? And then we could make some way of inside that talking about properties that grid square has. You know what I mean? Like, what are the points that we care about that are related to this particular object, right? And so what we want to do there is just have a few things that we can specify. And so, for example, you know, maybe we want to do like two types of attachments. So like attach to, or like, you know, we want to have sort of attached parent, you know, and attached child or something like this, right? So in other words, if you put a hat on a head, that's where the child would attach. If you put the head onto a body, the head is saying what the parent attach point is, the body is saying what the child attach point is, and they match up. You know what I mean? And I don't know that right now we have anything that doesn't follow that basic pattern, meaning there's only attachments that go on that way. I don't think there's any other kind of attachment. Like, I don't think we need to contemplate that there are attachment like slots, right? Attached parent is obviously unique, but attached child, you know, you could imagine there being like multiple places to put something. And I think we can cross that bridge if we come to it. I mean, it's pretty easy to augment whatever we do here to have that, but at the moment, I would say I don't know that we really need that, because I don't think we're going to have that. I wish I could think of a place where that would actually be necessary. But I'm just not I'm just not thinking of anything off the top of my head. So we'll see. You know, we'll see where it goes. If we want to be future-proof, we could. You know, we could do something there. Maybe when we're in there, we'll make it so that thing can be an array. And we'll go from there. But, you know, if you imagine something like this, which just said, look, here's a grid square, and then for that grid square, we're going to attach a bunch of information. Then what we could say is, you know, all right, the parent attachment is some position, right? You know, it's like this kind of thing. You know what I mean? And then the child position is some other thing. Like so on. And I want to say that we probably want scale as well here. So, you know, I want to say that we probably want some way of saying how big the thing would be. You know what I mean? I don't know how we want to specify that, but something where we would say, you know, if you attach me to anything, I'm, you know, half the size that normal stuff would be. Or like, here's how big I am. And so, I don't know, that might be something that we want to specify as a scale, maybe just in general. So, you know, maybe we would say something like this. You know? And so that would just allow us to change how big the thing is in the world, right? So this is like how many meters the thing is, or who knows what. and maybe I'll say size because it's not really scale. You know, it's like, oh, this is 4 meters big or 0.4 meters. You know, who knows, right? Something like that. And then on here, what we could do is say, you know, when you do an attached child, you can also specify the size, right? So you would say, look, it's, you know, anything that I attach gets a scale value. And you know, maybe you could just say it this way. Right? So like anything that attaches to me gets it, instead of it being its normal size, it's like 1/10 the size. The reason I say that is because, you know, like let's say these hats, we kind of just want to play fast and loose with them. So, you know, you put a hat on one of the hero characters, well, not one of the hero characters, one of the orphans, like so the hero or any of the orphans. You know, it's going to be a particular size. We then put it onto like the cat, it's going to have to be smaller. So we would want the cat to say that. Like the cat's artwork just says, look, when you put something on here, it gets this much smaller, right? So I think that's basically all we need there. Yeah. Trying to think if there's other stuff we want to do, but I think that's basically it. So we want something like this. This is the size value. This is a scale value. They're different, right? This is basically saying this is the percentage of the size of the child to use, and this is saying here's how big I am, generally speaking, when I'm not being scaled, or at a scale of 1.0. So I think we could do something like that. Attach parent, attach child, both would just be percentages inside the square, and I think then we'd be good to go. So I think that's pretty good. Here's what I will say. I think we also want the ability to be a little bit more broad, right? So I think we want to be able to say something like, well, okay, you know, by default, the size for like some range of the squares is going to be, you know, this, and by default, the range of the other ones is going to be something else or whatever, right? So it would be nice to do something where you said, you know, maybe something like this. So you could just say, look, the default size and child scale are this, and then I'm going to specify some specifics here, which can override them if you want to. I'm trying to think of like how I would want to specify that. Because typically speaking, we're going to want at least 2 of those. You would want 1 for up here and 1 for down here, right? And so you'd want to be able to do something, and I'm not sure exactly like how to do this. But you'd want to do something that looked like that, you know? Where you could just say, look, for all of those, that's what it is. And for all of these, that's what it is. Not sure what the best way to annotate that is, because there isn't really a way to do that in C. There's no, like, we don't really, if we're trying to stay with sort of C-like syntax, the ranges are really the issue. But you can, you know, imagine these getting applied in this way, right? And so we could do something like that, where we've got different things applied, and then any individual one can also be specified, but in general, like, you just read these in order. So this gets applied to all of these, this gets applied to all of these, and then this gets applied only to this particular one, you know? That seems fine to me. Like, I don't see much issue there. I don't know how everyone else feels about that. But that seems like a pretty reasonable syntax, and I don't know that we really need much else there. I think that's all we would actually care about. Yeah. All right. I suppose the other thing that I'm not really sure about. So one thing that's a little bit weird there is trying to understand exactly how those things would be edited is a little tricky. But I feel like you could pretty much just do those directly, and I think we'll probably be fine. So if we were gonna put these in the HHA, so I'm gonna load up file formats. So if we were gonna put those in the HHA, I have to think a little bit about how we want to represent that. So I kind of almost feel like that wants to be its own array almost. It's hard to say. If you look at the way the HHA bitmap is defined, then align percentage is attached parent. So we have that in there currently. And the question is just, should we augment that structure to effectively have a bunch of markup in it? We just say this thing is pretty big. So it's got, a whole mess of stuff. So the size, the child scale, the parent attach, and all that all goes in there. And I'm not sure. My guess is the answer should be no. And the reason that I say that my answer should be no is because the HHA bitmap, I believe, is streamed in. And so really, this is where you would rather... oh, okay. Well, so it isn't streamed in. So we do have that loaded. So I thought maybe this data was part of it. So, okay, so that's fine. No, then it can totally go here, right? That's totally fine. I just wanted to make sure that this was always accessible to us at all times and not something that got streamed in, because I want to be able to know this information without having to stream it in. And so that's good. I'm relatively happy with that. So yeah, thinking it through just in my head, I guess I would say it probably belongs there. And that's a reasonable place to put it. Having to attach things that may actually be separate entities becomes kind of interesting as to how we're exactly going to handle that. But I don't think at the end of the day it's really all that difficult, because once we know where the entities are, then it's really just the same as having traversables. So I think what we'll probably end up doing is traversables when you actually say, I need to place this thing on this particular traversable or whatever. I think all you really have to do is then say, oh, okay, the same kind of thing happens for placing stuff like hats, which would maybe be a separate entity, onto a particular character, right? And yeah, again, this is sort of stuff that we're gonna have to feel out over time, but just thinking it through, that all sounds pretty good to me. So yeah. I think I'm good with all that. I think that's all fine. I don't really know, but it seems okay. And so if we wanted to make this stuff be represented in here, let's say, right? And we wanted to augment the file to have these, then what I would do is say, in addition to the dimensions of the bitmap itself and the align percentage here, right? What we would want to do is have the child align, right, which is this bit. We would want a child scale value and our scale value. So we'd really want to just have these, something like this. And so really all we'd be doing here is saying, in addition to storing the dimensions of the bitmap as they actually are, we've got a ton of like floating point stuff now here that we're going to pack in there as well. And this is, you know, going to be parent aligned, to kind of go with this. And if we just adopt this naming convention over here as well, which seems good, I could say that. Oops, that's not right. That was already correct. And so these would just be directly imported into the file, right? I guess that's all I have to say about that. We can, like I said, try to plan for future expansion there by saying, if we want more alignment points per bitmap, we can make that child align be fattier. So you could say, you know, you get 8 of them or something. I just don't know to what extent that really makes any sense, because I don't know how we would actually differentiate between those attachment points in the first place. Like, we would have to start like naming them or something, right? You'd have to start saying, here's the child alignment point and what kind of alignment point it is, right? And we could do that if we wanted to. You know, I don't know, maybe we should. I guess it's kind of free for us to do so. So we could do something like, you know, this. So you just say like, look, this is where a hat goes. and here's where my belt goes or something. I don't know, right? So you could imagine something like that, where you just had like who knows, here's top of head, and here's something like that, or like base of neck, right? We totally could do that. And if we did want to do that, then, we could imagine augmenting it with something like this. So we could essentially say, okay, there's an HHA alignment point, and an alignment point actually has a lot of information on it. It says, like, how big the child should be that goes there, what type it was, so what kind of alignment point it is, like that. Who knows? And just the location, like where it is, something like that. So then we could say, well, now, you get some of these. You get HHA align points. And you can just put those on if you want them, and then you can attach things to other things, and off you go. And then when we talk about this one, how this one attaches to other things, what we could basically say there was, well, okay, so we also have an HHA align point for the parent, and that maybe only has one, and it's the same thing, right? So, you could treat it like this, where you just have, like, here's the parent side, here's the child side, and this stuff is just not there, right? And maybe get 7 of these total, and one of the other one to make 8 in all. So if you look at that, that actually, it's pretty good, actually, now I think about it. It seems pretty reasonable, because now we can basically say, all right, I've got one point I specify, which tells me my size relative to my parent, right? Where it is on me, and what I am trying to attach to. So basically, like, the heads would all have base of neck as their attachment point, because that's what they're trying to go onto, and so we could encode what it's supposed to stick onto. Then in here, when we got child points, a body would have a p% of where the neck was, a size of probably 1.0 on heroes anyway, because it's not going to be smaller than normal. And then the type would be base of neck, so those two would match up, right? And that way you could just look, when you want to put a bitmap on another bitmap, you can just look to see where there is a point that is the same as the point that the thing wants to attach to, and you just use it. So that would give us the ability to have lots of different attachment points on things. And, obviously, each one of these, right, has a total of 4 4-byte values. So it's 16 bytes per, right? And so really you could even be more generous here if you wanted to be. Also say have a none value. So, we could even make it considerably more. So in case you wanted to have something that has stuff stuck all over it for some reason, or wears multiple hats because, you're making Portal 2 or something, you could do that. Now, it seems pretty good. The only thing I would say is, does rotation need to be in there? I mean, it could be that you want to wear a hat like on the side of your head versus on the top. I don't know that that really works particularly well, so I don't know that we want to have that in there. Seems iffy to me, kind of. But there you go, right? So I think that's mostly everything we would need. So it would look kind of like that. And this stuff by default would just be like zeroed out. Or set to 0.5, 0.5, and 1 as default values might be more sensible. Yeah, and that'd be that. Well, I mean, really it can just be zeroed out because if the type field was HHA bitmap align none, then you know it's uninitialized and can't really be used for anything. So that's fine too. So I guess I'd put one more in here, which is if we're just free floating in the world, like we're not actually attached to anything, then this is the one to use as well. Right? And I guess when I think about that, the only thing I'm not sure about is if there's something that wants to be in both places and wants to specify different values, does it imply that you sometimes need multiple parents as well? Right? So I guess what I would say is maybe we just go absolutely nuts with this and just say like align point 16. And then we just say, all right, and we say, look, if you set the high bit here, right? Which I technically don't know if it'll complain about this because C++ is terrible and always is bad at everything. I don't know if you're allowed to have a high bit because I want to say that it maybe only wants these to be signed or some stupid thing like that. But we'll find out. So if we were to say that, let's take a look here. Yeah, so this would have to be a bit larger to have that many. I wonder how many we could have without making ourselves larger. Not much, huh? $13 U64s. So there's one U64. So that would give us 12. So we would only be able to have 6 if we were gonna have the if we were gonna stay inside the size that we previously requested for these guys, which is 128, 2 cache lines wide. Since I don't know that we need that many of them, I guess I would be inclined to say maybe we just leave it at 6 for now. Because since the HHAs are just the resource format, it seems like we could add more if we needed them later and then just rebuild the output data. So it seems fine. and then we don't expand our footprint at all. It keeps it relatively clean. And we could also, if we wanted to, we could be a little bit more judicious with our use of sizes in general. So, for example, we could just make these more concise as well, right? Like we could say that this is all done this way, and it really wouldn't affect things much, right? So you could do that. And then you could have twice as many, right? In the same size. So, you know, we could do something like that. For p%, this seems very smart to do it that way because you don't give up any precision. You effectively have exact same precision. For size, it's a little bit hard to specify what that would mean because you'd have to say, well, how am I specifying this size in the first place? Like, you know, how do I encode the amount of scale that I want into a U16? But I still think it's probably pretty easy. I mean, we're not going to encode sizes of like more than, you know, 50 or 60 or 100 or something. So if you assume that you can, you know, you've got 65536 total values, right? So 1 over 65536 there is that. If I multiply that by 100 to say that the maximum scale is 100, then you'd still have precision all the way down to like 0.002 at worst, right? Which seems fine. So we can do it this way and then have a lot of them and still not take up very much space either. And the type field, again, not a big deal because we also know for that field, I mean, there's only going to be like 30 or 40 of these in our wildest dreams. We're not going to have 65,000 of them because, oh my God, I don't even want to know what kind of a world we've created if we have 65,000 different ways that things can attach to each other. The designers have gone crazy if that's what happened, right? So I think that's probably good. I think that's roughly where we would want to be. And so if we just go ahead and clean that up a little bit, then I think we're good. I maybe would say that HHA bitmap aligned world is maybe not right. Maybe there's default. So in other words, if I don't know what I should be doing, then I use this one. So if you attach me to nothing, like I'm floating in the world, I would use it. And I'll also use that if you attach me to something I just don't know what it is. So like, you know, I attached you to top of head on somebody, but you don't specify top of head, then I'll use the default if there was one specified. You know what I mean? So there's kind of like a fallback procedure there where, you know, default will match anything, and it's overridden if you can find a specific match. You know what I mean? So that seems reasonable. Maybe, possibly, who knows? And that would allow you to specify 12 alignment pieces of alignment information, which seems good, and hopefully would get us past anything that we might need to do. But again, we could also expand that if we felt like we needed to for some reason. So I think that's okay. Again, these are for U16s. So this right here, oops, excuse me. So this right here is 8 bytes, right, per, I want to say. Right, 2, 2, 2, 2. So it's a total of 8 bytes. Which means that, you know, let me just think about how much that would be. Yeah, so 12 8-byte alignments, right, is 96 bytes, and then we've got the dimensions here that are specified. That gives us some more there really is no way to trim that down in any way that we probably care about, because we could change that to E16, but it wouldn't help us get an extra alignment point in there, so I'm not sure that we really care about that. What we could do here, though, however, we could do something like this. And so that way all of these things are encoded in U16s, so they're all going to be the same size there. And then we'd have two more to play with here in case we needed to use those for something else, and we just clear them to 0 normally. The other thing we could do there, so the bitmap dim is specified, but the other thing we could specify there is what the original dimension of the bitmap was. I don't know if we really need that for anything. I don't think we do, because we could just use that to set the initial size parameter inside the align point. And so I don't know that we care particularly much about what that original dimension is. We just probably don't care. So I'm going to say let's leave it like that. And let's verify that if I up this by 1, that we aligned it right. Yeah, the size is wrong. So I think that's everything there. If we look here at when we're in the HHA editor and we're dumping the information, the alignment information is now incomplete because we've got multiple alignment points that we might want to print out, right? And so what I'd like to do here is augment this when we see a bitmap. I'd like to go through and actually print out all of the alignment points. So I'm going to say, well, let's call it point index. I'm going to say asset, equals 0. Point index is less than array count. Did we cast this bitmap? I think, yeah, we did. Bitmap align points. So just iterate over all of them. And if it's specified, then I will print it. So HHA align point equals bitmap align points point index. So I've pulled out that point, and I'm just going to look to see if the type is not, none. Then I'm going to print out the data from that particular point. Now, while I'm printing this, I probably want to use indentation of some kind, so I probably want to do something like this. And I probably want to do that if it's not the first one, right? So I want to do something like in here, if something like that. So, if this is the first one, then let's just mark the fact there's alignment in this thing. And then we'll print out that particular point. So, whichever one it is, which is point index, we'll say, here's this one. We want to print out the type. So we want like a line type name from, and I'm going to say, whatever this type is, give me back a string I can print, right? So in here I can say what type it is. And then I want to be able to print out this stuff. So the p%, the size, the type we've already said what it was. So we just need these two now. And so in there I've got point p%. And just to make that back into a float, because these are encoded like as U16s. I probably want to say something like this, right? So we can look at them as percentages rather than looking at them as U16s, because, you know, that's the way that we've encoded it. And the size is another one of those. Now, because this is something we're probably going to do frequently, we may want to bake that encoding into a function. So we may want to do something like, you know, like this. So we can pass in one of these points and get the decoded version in a predictable way in case we want to change the encoding later. And again, as you know, I am not a fan of using get or set functions. I think they're dumb and a waste of everyone's time. But once you actually have work to do, then they're a good idea, because hey, now I can just have that work done for me and I'm actually creating a function that does something, not just wasting everyone's time. And so in this case, since we've already got that happening, everyone's going to have to do this work. Let's just make that a utility so that everyone can call it. And that gets us both things. It allows us to change how we encode it later, and it makes it easier for the people calling it, so it's a win-win instead of a lose-lose, like it would have been if we just added it for a bare value, like type, for example. So that allows us to recreate the percentages, and then I can just do that instead. So I can do p% equals get p%, and then I just pass the point that I'm asking for here, and then I can just do p% x, p% y, and it's, you know, much easier for me to use because now I don't have to understand how those values are encoded, because they are encoded. So get size would be the same way. You know, it's something like this, but it's not exactly this, and that's the thing that, like I was saying before, is a little bit confusing to think about, right? So if we did this, then you could represent any size you wanted up to 1.0, but you couldn't represent more than 1.0. And so what I think we want to do here is say, look, there's a additional multiplier on the front end that just says that's the maximum scale you can ever scale something, and everything else is going to be less than that, but it's still significantly more than 1.0, right? And that seems reasonable to me, so I think that's what we'll do. And you know, I could also, just for uniformity's sake, do it this way. Just makes it easier to inspect those values and debugger when we're, you know, invariably stepping through this because we want to verify what's working and what's not and so on. So there's their point index, there's the string, there's the 3 values that we want to know in terms of the location of things and their size. That's all we really need for this part of the process, but we do need a way to get this data in here, and you know, it's the same as you can see. We've got the same stuff that we're talking about here for other things, like how to get the tag names and so on. And so what I'd like to do there is just say, yeah, let's do the same thing for the align names, and I should probably just follow exactly what we've been doing, right? So, you know, this exact thing we should probably just do for the alignment points as well, right? So in here, when we say align type name from, just like we had here, and you know, I guess thinking about it going forwards, we're probably going to need this to be parsable too, if we do have these in a string format that we're saving out. So really, I think we want this whole process, like this whole thing, probably needs to be there as well, right? So I'm just going to go ahead and copy this and put it in here. And so what we're going to have here is, excuse me, This is a line point name or a line point type name, something like that, right? And this would be a line point type. I don't remember what that was called. There you go. And so this is literally just going to provide that same exact kind of translation table, but for a different type of thing, right? And so in here, we've got this many of them. And it's going to be a little bit different. Excuse me. So there is a little bit more we have to do. So it's not as straightforward, but it's pretty similar. So that's what we expect so far. And then in here where we go to pull this out, if I say, instead of tag name from ID, if I say a line name from type, nope. So if I pass one of those types in and then we look it up, we would do exactly the same thing here. We look through all of the names that are in the mix. We look at one of them and we see if the types match. And if the types do match, then we just return whatever the name of that one actually is. If not, we just return unknown. And the same thing would happen here. So HHA bitmap align type. When we look through here, we say align point type from name. You pass in the name. We search through the list. So it's not an asset tag ID. It's an HHA bitmap align type that comes back. We assume that we can't match it, so it's a none. We look through all the names, and if we eventually find one that that matches, then we return it. Right? So the only thing that's important to remember here is that when we're working with these, we need to also check for the parent flag, because that's going to be welded onto the type field. And so, you know, we want to be able to crack that as well. And so one way to do that is to parent, and you can pass that in here. And that just says, okay, you know, if the type has that flag set, then it is. And then the other thing you can say is get me the type. So here we would say I want to cast this to an align type, and I want to only have the part of the type that doesn't have the rest of it in it, right? Like so. So we have, yeah, I was gonna say we have this, so I'm gonna go ahead and put those in here. Just so we can expand them out a bit and see them clearly. And again, this is just all of the encoding and decoding work here. Well, it's really just the decoding work. We haven't done encoders for these, but that's, you know, probably less important. We may not actually need those to be their own functions because less people are going to be doing that, possibly only one person, and then we can just have that in line. All right. So now you can kind of see those a little more clearly there, but what they're doing is very obvious, right? So I've got the align points there, and I can crack out the data from them. Now when I do, when I need the information from them, I can say, oh, is it one that goes to parent or not? And what's the type? So that way, you know, when I'm actually, oops, I don't know what happened there. When I'm actually doing something like this, if I compile it, it'll give me an error because this is not, oh, well. It'll give me an error because it's named wrong, but that wasn't actually what I was going to say. What I was trying to say is this error is one I wanted to explain. So it'll give me an error because it's not the right type, and that's good because really this isn't that type. This is the type with a possible flag welded in at the top. And so what I want to do is have a way of getting the align type here from this, and that's what I'm going to print, which is cracked. And then I would say, you know, is it to parent? And that's yet another thing, right? So in here I would print this, and then I'd also want to print something else, like, does it attach forward or does it attach, you know, I don't know how we want to write that. Probably I'd want to write that as like outgoing or incoming. So maybe I would do this. I don't know, this is hard to say, but so if it attaches back to the parent, it looks like that. If it attaches to a child, to something on the other side, you know what I mean? Honestly, I feel like it maybe should be written like this. So like, if it goes to the parent, then you'll see a little thing that sort of says like it's going back that way. So it would meet something on the other end. And then if it's not going to the parent, then it's an outgoing connection and would have a thing going that way. You know? I don't know. Don't look at me. That's all well and good. Change that to a line type there. And I think that gives us what we want. The only issue here is our %s's. I don't remember if we ever actually fixed those so that we could print strings okay. It looks like we're still doing dot stars for those. And I'm not sure that that's like such a good idea because you can see how annoying this gets, you know, with all the dot stars. So I kind of feel like to a certain extent, you know, I don't remember where we put this stuff. Probably in utils, right? Because it's just or shared or something. Yeah. So in here, you know, when we look at what the type of the thing is that's coming through, in here you can see us grab a string, and we could instead just have another case where we know that there are strings that just get pushed on as strings. You know what I'm saying? And it would require us defining a different letter code that's like non-standard, which is a little bit bad because compilers now have welded in checking because of course that's how they chose to solve that problem instead of just letting you write your own checking. Yeah. If you want to know how to do this correctly, go look at how John did it in his language. It's actually correct. So you can add your own codes and check them, which is kind of the obvious thing that someone who programmed computers for a living would do, and therefore not what the C++ people do. Whatever. So what you want to do here is you want to go, well, is that worth it? I think it probably is, because this is just super error prone. Like, it's just not good. And so constantly having this notion of how things are going to be casted and dealt with, it's just bad, right? It leads to a lot of error proneness. So I think because we're using that more here, I just want to go ahead and support that. And so let's say we did add one here, you know, I don't know what would be an unused letter, but like a capital S might be an example of something reasonable to use. And if we then just grab this here and do the exact same case, really all we're saying is that it's mostly the same as this case, but we're grabbing out a string like that. So we're going to get a, you know, this kind of composite case, right? And so when we do this temp equals thing, we're actually going to do it this way to grab it out of the buffer. I don't know why we say obey precision and then we proceed to obey the precision. So I think maybe we were only talking about width there or something. I'm not sure. So that's a little bit hard to square. I'm not sure what that to do actually means in this case. But if the precision is specified, then here we say like, okay, you know, well, it's less than precision, take a look at the size or whatever, and then, you know, otherwise we use the full length of the string. So what we can do here is something a little bit better. What we can do instead is say, look, set temp dest size equal to what the string's length would be, because we know that we already can get that for free. It's with just a known value we load. And then if the precision is specified, then all we have to do is use the lesser of the two. So if you specify a particular precision, then rather than doing this, we can just say, all right, if temp dest size was going to be greater than the precision, then clamp it down to the precision. But otherwise, you don't need to do anything, right? And so, you know, we can even make that part of a compound predicate here like this. And so if we would need to clamp, then clamp, otherwise don't. And then when we get the temp dest out of this, we would just say, okay, however much I assume we want the at to always be at the end, it looks like. So we just want to advance to how much we do. So that's fine as well, right? So I think that would just output a string for us directly. You know, with no other fuss and such, right? Let me take a look at where that was trying to happen. Oh, sorry. So why isn't that... Okay. So it sets, so this is just, I don't know why we wrote this like this. So this is just temp as well, right? So I'm not sure why it wasn't written like that, but you know, it wasn't. So I'm not sure. Anyway, so what we can do here now is just say, look, that's a capital S, and that'll print that out. Oh. All right. Looks like somebody... Oh! Oh, man, I take it back. We're not using our string out, are we here? That's unfortunate. Well, I tried. I tried to be good, but we're not using our runtime library, so that's unfortunate. That's really too bad. We tried, right? I mean, we tried. We tried to make a good system, but again, you know, yet another reason not to use the C runtime library, right? Can't make your own printf. So yeah, I guess I'm okay with, oops. Guess I'm okay with that. I don't love it, but that's where we're at. now that that's taken care of, I think we're good to go on the HHA edit front. But now we got to go in here and do some other saucy maneuvers. Now, one thing I should mention is that when we're loading the HHA bitmap v0s in, yeah, so in this case here, we need to have this be an HHA bitmap v0 because we did update how that's stored, right? So if you look at, I mean, this is not really necessary because really what we should do eventually is just be able to rebuild them without having the old ones ever loaded. But, you know, it used to look like this. And so, you know, if we want to continue to have the ability to load that old format, we should respect it, right? So that's the way we were doing that. And what that implies is that here, when we actually load the data in, we can't actually do a trivial conversion like this anymore. What we have to do is actually convert the data from the old format to the new format so that we properly include it. Now, that's not particularly hard to do because in this case, it's really pretty straightforward. We clear the bitmap asset out, I believe, to 0 first. Or at least I hope we do. Let me just see if that's actually true. Null asset. Yes. So we clear it out, so everything's set to 0. So we only need to set fields that we actually get from the original one. So if we look at what those are, right, they're just the dimensions and the align percentage. Oops. Right, that's what we're actually going to get, but we need to encode them differently. So when we actually set the encoding for these, we probably want, like I was saying, to do an in and out. So for things that are getting encoded in multiple places, we probably want to be able to do those in and out. So for align percentage, I'm going to read it out of the destination like so. There we go. So align percentage of 0 and 1. Kind of want that to be here, but 4Coder thinks otherwise. So that's that, right? So I can get my align percentage like so, and then I can get my dimensions largely directly. And the only difference here is I have to truncate them to U16, but we know we don't have any bitmaps larger than 65,000 pixels, so this is free because we know all of the V0 assets that exist and none of them have that. So once we grab that, we copy this, then all we need to do is generate one synthetic align point that mimics our old one align point that we had, right? So in align points, 0, which I think I'll make it a little easier on myself and just, well, maybe what I'll do here actually is just do one encode that kind of writes the whole thing. So maybe what I'll do is something like this. So set the first align point, right, and set it to when I'm what I've got here, right? So it's an align point that goes to the parent. It's not a child align point, right? So I want to say that it's to parent. I want to say that it's the default, right? Something like this. I want to say that the size is 1.0, and I want to say that the align percentage is the thing that I read out of the source file, right? Now, I don't know if I really want to OR these two together, but maybe I do. So maybe I would just say something like this. The other way I could do it is comma true and have it do the OR. Maybe like that. I don't know. I'm of mixed feelings on that. Because on the one hand, I not doing the OR makes it so that I can pass a Boolean pretty cleanly here from some source. On the other hand, when it's bare like that, it's a little bit ugly. So we'll see. But anyway, let's just call it that way for now. And then what I'm going to do is inside here where we've got the stuff that does the decode, I'm going to put in a thing that does the encode, right? And so what I'll do here is just say, pass me an align point as my destination. And then pass me an align point type. I don't know why we didn't just call this align point type, or maybe we did. I feel like it's a little weird, right? Like, this is called an HHA align point, and this is called a bitmap align type, which is dumb. It should look like that, right? There we go. Let me just clean that up a little bit. There we go. All right, much better. So anyway, once we get all that in there, we should be able to just do one that trivially sets it as well. So when I've got this destination, let's see here, to parent, I don't know, whatever you want to call that. And then we've got our size, and then we've got our p%. Here's all the information that we want to set in this thing. And what I'm going to do is just fill it out, right? So I'm going to say, okay, we got the p%, we got the size, we got the type. This is all the stuff that we need to actually, excuse me, put in there. And so I will say, this is the type, ORed with to parent. And so there we're just saying, look, if we know the type goes in the type field, we know that to parent is going to OR in either the to parent flag or nothing, depending on whether it's set. And so that'll take care of that part of it. The size, we then have to encode into a range so that we can use it as a 16-bit value here. So what we want to do there is say, for both that and p%, we want to essentially do, look, we got to cast this to a U16, but first we got to convert it. So when you pass in, like, you know, the p%, whatever that p% values x is, so I got to do this twice. Whatever that p% values x is, I just want to blow it out to however big a U16 could be, and then leave it at that, right? So literally all we're doing here is saying, look, it's a 0 to 1 value that we're talking about. So when we go to read it, just multiply it by 65535 and store that as a U16, because we know that's the way we're going to reverse convert it later, and that'll be the closest we can get to the input floating point value. For the size, we'll do the same thing. We just say, look, we know we've got this funky kind of like you know, the other way to look at this would be, look, we're just solving the equation, right? We've got, you know, stored equals U16 max over P%. So if we want to get P% back, it's just, you know, swapping the sides. That's all we're doing. So anyway, hopefully everyone sees that, and I don't have to do it on the blackboard, but if anyone's confused about that, I can do it on the blackboard. It's just, I'm literally solving the equation, you know, if result.x equals this, right, which is what we're saying here, then obviously if what I wanted to do was get back what's being stored in here, then I just need to reverse this equation, right? So I need to multiply both sides by P%. So that clears it out of the denominator and puts it into the numerator, or not into the numerator, but onto the other side, the numerator of the other side. And then I need to divide by result x, right? Did I do that right? Not so good with doing math in a text editor. Wait, so that would be correct, but this is wrong. I was going to say that I did that math correctly, but this is not correct. Why did I write that way? That's what it should be. Right? All right, so glad I happened to do that out, because that was just wrong. Yeah, I don't know why I wrote it that way originally, right? Why did we do that? That was, I don't know, I guess I just must have not been thinking when I typed it in. But this P percentage is a value from 0 to U16 max, right? So in order to change it to a value from 0 to 1, we would want to divide by U16 max. So that's what should have been written here, not what I wrote before, which probably people on the stream already caught. Of course, I'm not reading the stream while I program as per the rule, but presumably someone saw that. Hopefully someone saw that. If not, then you're sleeping on watch as well. Anyway, let me do that one more time. So assuming that, you know, we've got this equation here, what I want to do is solve for this. So it's that. Which now gives us the answer that I typed in down here, which is what we want. But before we didn't get that because I had written this equation wrong. Unsurprisingly, if you write the wrong equation, when you solve it, you get a different equation. So yeah, so that's all I was trying to say there, and I'm really glad that I happened to digress there, because that saved me the trouble of having to debug that later and look at it and go, wow, why did I write that? So anyway, we should have a complete setting now for these, so we can get and set them, and they will encode and decode the sort of values into what they need to be. And I think that's fairly complete, right? This has to probably be cast to U16 because it's not a git, like the compiler probably doesn't necessarily know that it's U16 or not. I should double check, see what it says, see if it's telling me something I wouldn't already know. Yeah, I think it's just integral promotion, because there's nothing in there that's greater than a U16, but I guess it doesn't really know that. So if we now take a look at what's going on here, let's see, we've got a few places where these type names are wrong. Because I changed them to be easier to understand. And okay. So that's everything we need to do to handle HHA files in that new way, I argue. And then we also have, when we're actually doing work in our bitmaps, you can see there's some places where this stuff's actually used, right? And so when we loft some of these pieces of information up here, you can see us, we're relying on this information, and we now don't necessarily have it anymore, right? Like, we don't have an align percentage anymore to loft up into our bitmap. Now what we can do is just read the first one. So we certainly can just say get p% and just say, look, give me the one from align points 0, and off we go. So I have to put a to-do here. So we kind of need to make some more thoughtful stuff here. You know, we gotta think about this a little bit more. So we'll talk about that a little bit later, obviously. But as it is right now, we can sort of just keep that sort of out of the spotlight there. Inside here, where we're actually creating these, we're going to have to augment this significantly because this is where we want to now put the parser that can read this information from an actual source file, right? And so that's something that we have to take into account and do more directly. Now, storing this stuff, this is just a question of actually packing down to a U16, which is fine. And we may want to check here, but I don't know. Like, I'll say maybe we check here and record an error if it's larger than 60. Okay. Because maybe we do want to do that in the future. Don't really want to deal with it now. And so really all we're talking about now is the fact that these defaults were here, and now they're not going to be here anymore. What I'm going to do is, again, just continue what we were doing before, which is just say, look, let's go ahead and set this to the same default it was being set to, just for now. And then we'll augment that by actually parsing a text file and seeing if there's anything in it that we need to process there. So when I set this align point, I'm just going to say, like, okay, got these bitmaps align points. And what I want to do is then set it to exactly the same default values we were setting the other ones to. So in here, right, I'm just going to say HHA align default. I'm going to say true for the parent. I'm going to say that the size should be 1.0 and that the p% should be 0.5, 0.5. And then I'm going to get rid of this, right? So now that should completely mimic the original behavior. And our only issue that we have now is that our HHAs, we want to update them to the new format, right? So if I go to our data directory, right, like what you can see is we've got these here, and you can look, I don't remember where our V0s were, there they are. So you can see we have all these V0s, and we want to be able to use V1 files, so we want to be able to like update those V0s to V1s, right? So what I want to do here is delete those HHAs. Delete these HHAs that we have that are V1s here, and make the, sort of into V2s. Now, I'm not going to add support for converting V1s to V2s because we don't need it. And really, conversion can go away eventually because we can just go directly from our source PNGs. But what I would like to do is respect the fact that we changed it. So if anyone ever did want to, just as an exercise, it would be nice if they could go, oh, okay, we can actually tell the difference between all these version numbers. So I'm going to make the version number be 2 here and go from there, right? Now, in the HHA edit code path, let me just see here. Where is our read HHA? There it is. So what I want to do here is essentially say, look, we're not going to actually preserve this path because I don't care about it. So I'm just going to go ahead and do this, right? Like so. And so now if I actually try to HHA edit one of these files, so test1v1.hsa, it should tell me that it doesn't, oops, should tell me that it doesn't know what it is, right? And that's exactly what I want. So, you know, if I tell it to dump it, it should just not be able to do it. And so that's, like I said, we could support those old ones. I just don't care about it. So like, eventually the HHA editor can just lose backwards compatibility more or less for anything that we don't actually ship HHAs for, right up to the end of Handmade Hero production, because we'll just rebuild things from the PNGs and be fine. But once, if people start trading HHAs around, you know, when the game is released or something, then we would, if we updated the format, we would support both formats probably, right? Okay, so what I want to do now is just quickly check to make sure that this worked at all. So we'll just do a little debugging and then we'll call it a day. So I'd like to see if I can recreate these HHAs. So you can see local HHA is not an issue. That's not something we care about. So really what we care about is intro art, test 1, test 2, test 3, and test fonts, right? So that's what we want to actually rebuild. So I'm going to delete those, or I could just make a v1 directory and move them in there. Like so. And so we have to recreate these from these, right? So let's go ahead and do that. HHA edit, I believe we can just say rewrite. And we can pass one of these. So if we want to do intro art, then we can write intro art v2.hha, right? And so now, in theory, we rewrote that file that has the intro art in it. And in theory, I can read it now, right? And so we can see what's in it. And let's just verify that I'm right about that, because we want to be able to, you know, look at this a little more cleanly. Oops. And so in here, we should be able to see all of our assets and that they actually have something in them. So it's not quite right. So we're a little off. So you can see here that the size does not look right. It should be 1.0. And you can see that this is unknown. This is correct. So we're not quite there. Let's go look at why we got that happening. So we're definitely passing 1.0, and we're definitely passing HHA align default. And so what I'd like to do is just go in here and see, oh, I think I already know I forgot to end off that flag. So that one makes perfect sense. But let me just see why we got the incorrect size. So for our get size, yeah, we just never finished. We never finished, right? So for our get size, it's exactly the same as this, right? We've got an F32 here that we then need to scale up, like so. But because we want an extra 100 of range there, we need to first knock it down, right? So we need to say, look, take off some of what you were going to do there, like so. And that way we can encode up to 100 instead of up to 1. So that encoding's fine. The get type is totally wrong. I think I just wasn't, maybe the coffee wore off, right? We want to knock that off. So it should have been an and with the knotted version. So I don't know what we were thinking there, but just probably asleep at the switch, I guess. So yeah, let's go ahead and try that again. So now if I look at that intro art v2.hha, let's rewrite that a second time and see if we can get a cleaner version of that. Right? Where's my tab view at? I closed it. If I now open up the assets, let's see if we got a smarter alignment in there. So we've got a default alignment that lines out to the parent, which is what we want. It's 1.0 for size, which is what we want. And off we go. Now, what we can see here is there is a little bit of an ugliness here that sort of suggests we want to be a little bit more careful with how we're doing it. The fact that I can't represent exactly halfway is not particularly troublesome, but the fact that I can't represent exactly 1 is bad, right? And so it would be nice to look at why we're not able to represent exactly 1 there. And get it so that we can, because we don't really want everything scaled down by a little bit. Like that's actually not great. So if we look at when we're getting the size out, these aren't exactly reversed. So one thing we could do maybe is do them exactly reversed. So I think part of the problem too is 100 is not a power of 2, which probably is bad as well because it sets us up for being off by 1. Let's just try. I'm just going to say, let's try. When we actually have 65536, right, we're going to be dividing by, I'm just thinking like out loud here. So if I have 1.0 and I'm going to divide it by 65535 there, or I should say I have 1.0 and I'm going to multiply it by 65535. I've got 65535, right? And so when I actually do a divide there, you want to divide it by something that would evenly go into 65535. Right? And so, you know, if you were to divide by something that could go into it, so let's say 65535, and I want to divide it by, like, let's say 127, or maybe 126, 65535 divided by 255. So it can record that in 257 times 255 can produce that value. I don't know if there's a 126. I don't know what the factors of 65535 are. Is there like a factorize web page? There we go. So just looking at what the factors are here, 3, 5, 17, and 257, right? So if I was to take those numbers, you know, 3 times 17 is 51, 5 times 17 is 85. 5 times 17 seems like the best one to me. So let's say that that's the maximum. And that way you'll have an even number that you're then encoding into a U16 and encoding back out. And so you shouldn't have any weird divides at that point. That's my argument. And we can also as well stick it in this way, so we've done the multiply ahead of time to get it out of the fractional part. I don't think that will help at all, but wave a dead chicken over the floating point number and pretend you did something useful. So if I leave that fraction that way, I just want to see if that'll give me a better result. So let's take these guys out, and I'm going to do a rewrite, and then I'm going to do a dump, and then a tab view. And this time, thankfully, I didn't close my tab view. So looking at the assets again this time, there we go. So now I've got my exact 1.0, which is what I wanted. I don't know why I don't have an even 0.5, but I don't really care about that, so I'm okay with that. I wasn't okay with not getting an even 1.0 because I want scale of 1.0 in particular to be able to represent it exactly because it is the neutral scale. And so that was important to me. What I would like to quickly look at is just why we're not getting that direct in and out. So if I do p% .x and .y times UC max, I guess the reason is because of the rounding error. We might want to round these, and if I rounded this guy, if I had rounded this guy, it probably would have rounded us up to 1, which would have been fine. In that case, maybe. I don't actually know if that's true as I'm saying it, but that's when we do it. But this is probably would have to do with the rounding case. So when I truncate this to a U16, I want to, if I'm closer to the U16 that's higher up, maybe I should round it. So meaning in this case, when I do this multiply, I then want to do a bias of 1.5 to make sure that I would round up in the case where it's up roundable. Although really what I would like it to do is actually round. Meaning I would like it to do a rounding conversion because I don't want to bump it up to 0.5. So I don't know, like, I don't remember if our intrinsics have a round. So we do have a round real 32 to uint 32. And so what I might do here is say, look, let's round this. You know what I'm saying? And so if we round it, then we will get a more accurate result there. And that might be a good thing just to do across the board. So just all of these are just going to get rounded and then truncated. That seems better to me. I'm going to argue that's better. So let's try it one last time. And then I think we can maybe say we did our work and we're good to go. There's the rewrite. There's the dump, and then if I look at it here, let's see. Now, so the rounding is just, all it's doing is changing which bump I went to. So I'm still not thrilled with that, and that's probably just because the U16 max isn't evenly divisible by a 2, so you can't put a value directly in the middle of it, you know what I'm saying? And I guess what I would say is, again, I don't really know if I care for any particular reason. There's nothing special about directly in the middle of the bitmap. Really. So I'm not sure if I really care one way or the other. Maybe I do, maybe I don't. But if we wanted to represent it exactly, I think we would have to use a scaling value that was capable of representing the middle perfectly. And so in order to do that, there's a couple ways we could do that, right? We know that U16 max is not capable of being divisible by 2. It's pretty trivial to turn into something that is, right? I mean, you could just do this. And then you lost 165 5/3 of your ability to be precise, but I think at that point you've gained your ability to produce a halve again, right? Because you can specify a value that's exactly halfway between the two. So I think that's true. Let's see if it actually is. I should really make this into one command line here. Oops. And I did it again. So I'm going to go ahead and say let's leave it that way. It's better to be able to represent exactly half probably than it is to have that extra one value there. So I'm going to leave it at that. So okay, that's it really for today. But I want to really quickly see if we can run with these files just to see if there's anything else obviously that we did wrong. And so looking at the v1 directory, here's again the files that we actually need. So I'm just going to really do a quick HH8 edit rewrite of the v0 directory test1 v1.hha test1 v2.hha. Oops. There we go. And so now, I think we have all of our files, right? We've got intro art, we've got test1, test2, test3, and test fonts. And so now I can see whether or not we can actually run, and it looks like we can. Now, the only thing that's a little weird there is we need to import some stuff now, and we didn't really test the import path. So all of this stuff seems to be working pretty good. I don't see any problems, right? That all seems pretty reasonable. And so all I really need to do here is if I slap down a local HHA, it should run the import, and we can see whether the importer still does it properly as well. Meaning is it capable of creating a version 2 HHA that will correctly place everything. It looks like it is. So that's good. That verifies a bunch of things. Like it verifies that we can add stuff to our HHAs pretty easily and run a conversion that's really pretty straightforward. So that's good in case we need to modify the file format. I don't want that to be a huge pain in the butt. And now I think we've got roughly what should be in there. And so that's all good. I'll go to a quick Q&A and then we'll wrap it up. Alrighty then. Let's see here. Oops, no. God, I really wish Linux could understand how to access a mouse. Um, 85 isn't a factor of 65534. Yeah, but we don't care. Those are they're two separate equations, right? So this equation is the one that uses the 85, and it's still using 65535. This equation, which does not use 85, is using the -1. Let's see. Could you use U16 max +1 in a size modifier of 128? Probably not, because you still want to be able to represent 1.0. I'm sorry. Okay, I see what you're saying. You're saying for the sizing one. Yes. So yes, I think you could do that. Yes. Color seems like it would make a nice addition to the bitmap parenting system. A ghost wearing a hat should not have a hat with a lower alpha value. So color is actually something that it gets is on the property side of things. It doesn't depend on the artwork really. So no, I don't think that needs to be encoded into the bitmaps. Like whether or not something's a ghost is actually a property, and it can be propagated to children just as easily if we want it to or not. It doesn't have to be in the artwork. Last week you were mulling over whether or not to separate the head from the body in the sprite sheet. Since then, has this idea become more solidified? Now, we haven't really looked at that part yet. Also, do you plan on giving some of the faces more articulate animation? An example I thought of at the start of the stream today was blinking eyes on the cats or other characters, perhaps as overlays of eyelids with versions of for each head angle. Yeah, we could do blinking. I don't know that I care about that right now, but it's pretty easy for us to add, right? Because we just have a blink tag that's like a 0 or 1. Let's see. Totally random question, very off topic. Do you like that the C++ preprocessor has no special syntax for invoking a macro? Are there merits to that in your mind or not? Would you prefer a special syntax for invoking macros? No, I would say it actually the opposite way around. I would say that the C++ preprocessor does have a special syntax for invoking a macro, and that's bad. A macro processor is supposed to be a way that you can modify code that's written to do one thing to do something else. It's the whole point of a macro preprocessor, and there is no other point, in my opinion, of a macro preprocessor in the first place. It's basically for metaprogramming. It's for reaching into something that was written textually one way and changing it to be written textually another way. So I would argue that actually the biggest limitation of the C++ preprocessor, besides the fact that it's just really underpowered in terms of its ability to program things in general, and the fact that I don't think you should need a preprocessor, your language should just have the ability to do metaprogramming in it. If you ignore those two things, I would then say if you're actually having a macro preprocessor in the first place, it should allow arbitrary matching syntax so that you can reach in and grab anything you want. It should be the case that you can create a C++ macro that matches against A plus B in the middle of the text. So it can, for example, replace infix notation instead of just postfix function calls as things that can be rewritten, right? It's kind of just obvious that you should be able to do that, and I don't know why you would do it another way, but, you know, there you go. All right, I'm gonna close it up. I will leave that as it is. If someone wants to raid a bug on the GitHub about switching the camera movement, by the way, I'm fine with keeping it consistent so that left-right is congruent with up-down. But I probably won't remember to do that by the time we get back there. So, you know, if someone wants to put a bug in there so we get to it eventually, someday when we're doing bug stuff, we can do that. All right, thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so that you can play around with it yourself and try to learn along with the series. I will be back here tomorrow when we will try to parse some files to do the annotation that we added support for today. And while that probably won't take too long, it is a little bit of busy work, so, who knows. If we finish it tomorrow, then what we'll start on is just some understanding inside the code of how to use those alignment points. So we're going to have to add some code that does the thinking of like, oh, okay, I'm snapping this to this. So here's the alignment point I use or whatever. So that's going to be a little bit of work too. I think that's mostly all the work we have left to do in terms of importing characters and having them, animate properly and do stuff like that. So hopefully that'll be done probably by next weekend. And then we're free to kind of drop characters in the game, just like we were currently free to drop environment stuff in the game. And we can start playing with that a little bit more. I guess it also allows us to control how furniture gets set up and stuff, which we kind of want to. So it's actually good not just for the characters, but it'll also allow us to have more useful control over the not just organic entities, but actually inorganic entities too can use those attachments and things like that for other purposes. All right, that's about it for today. Hope to see you back here tomorrow. Till then, have fun programming, and I'll see everyone on the internet. Take it easy.